We're going to be looking at applications and modeling with quadratic equations in this lesson. Something that hopefully is familiar to all of you is the Pythagorean Theorem. If you recall, Pythagorean Theorem is a very helpful tool in finding side lengths of a right triangle. Not just any triangle, but it has to be a right triangle. And so the Pythagorean Theorem says if we know two of the three parts of any right triangle, we can find the third side of that right triangle by using a squared plus b squared equals c squared, where c is always representative of the hypotenuse. Now, if you look at the example that we have, one of the things that I want you to do is to just listen to what I'm going to say without looking at the diagram. And we're going to talk about how you would be able to solve a problem like this if you haven't been given a diagram. So let me read the problem to you. I know if you've printed off the notes, you see the problem written out as well as those sides labeled, but I want you to be sure you can practice how to properly label the sides. So it says a piece of property has the shape of a right triangle. The longer leg is 10 meters shorter than twice the length of the shorter leg, and the hypotenuse is 20 meters longer than the length of the longer leg. And we're supposed to find the lengths of all the sides of the triangular lot. Now, one of the things you want to be sure that you pay attention to is when you read a problem like this, if you recognize that there is a shape, a geometric shape mentioned that you're able to draw and it's not provided for you, then you're going to follow number one in this little box. If no diagram is given, then you want to draw one. So the first thing we're going to do is draw ourselves a right triangle. And when I do that, I want to try to make a distinction between a short leg and a long leg on this right triangle, because I heard those words when I read through there. So I know that those two legs, the two sides that form the right angle, aren't going to be the same length. One has to be longer than the other. So we've done the first part. Now we've got to identify how to label these sides. Now, if I read the next sentence again, it's a very long, wordy sentence. The longer leg is 10 meters shorter than twice the length of the shorter leg, and the hypotenuse is 20 meters longer than the length of the longer leg. Now, if it had told us how long any of the legs or the hypotenuse happened to be, that would give us a great starting point. We would write that number down, but nowhere were we given a specific length for any of the sides of this right triangle. And that means we're going to have to label one of these sides as X. Now, I do want to scroll back up for a minute and let you look at these words, and I want to point out a couple of things to you. Okay? So what we do see is that there are some comparisons going on. We see the longer leg is 10 meters shorter than. You want to look for these comparison statements such as shorter than, longer than, and so forth. So I see the longer leg is 10 meters shorter than twice the length of the shorter leg. Now, how that is helpful for me is when I see that, whatever follows than is my starting point for X. But what I'm noticing here is I see another comparison where it says that the hypotenuse is 20 meters longer than the length of the longer leg. So here's what I've got to try to figure out. If the same side is following the than in both of these statements, that's an obvious, this has to be my x. If it's not the same side of the right triangle, then I want to try to order them to see this got compared to that, and that got compared to this bottom one. And whichever one would be at the end of the line, the starting point for the comparison, that's the one I want to call x. So if you look at this carefully, it tells us the longer leg is 10 meters shorter than twice the length of the shorter leg. So what I see is that the longer leg is getting compared to the shorter leg. But the second part of the statement says the hypotenuse is 20 meters longer than the length of the longer leg. So that means the hypotenuse is getting compared to the longer leg. So if I order these statements, I can see that the very bottom of the list, the starting point needs to be the shorter leg, and that's going to be the one that I call x. Now, let me erase this part, and we're going to go back up to where we're not seeing that diagram, and we're going to try to fill this in. So we decided that the shorter leg needed to be x because it was at the bottom of the comparison. Now, if I go back and read, it tells me that the longer leg is 10 meters shorter than twice the length of the shorter leg. So this longer leg is going to be 10 meters shorter than. Now, think about that for a minute. If I say, how much money do you have with you today? And if you told me $20, and I said, well, I have $5 less than you, then you would know I have $15. But be careful. If I have $5 less than 20, that's not 5 minus 20. That's 20 minus 5. So anytime you see that comparison that's a shorter than or a less than, it's subtraction, but it's written in reverse order. So since this told me that the longer leg is 10 meters shorter than twice the length of the shorter leg, that makes the longer leg 2 times x, because that would be twice the length of the shorter leg, and then I subtract 10. Okay, and the last piece to label is the hypotenuse, and it told us that the hypotenuse is 20 meters longer than the length of the longer leg. Now, longer than tells me instead of subtracting, I'll be doing what? Adding. And so if I take the longer leg, which is 2x minus 10, and then it told me that the hypotenuse is 20 more than that, I'm going to add 20 to that, and that gives me 2x plus 10. Okay, so we have translated all those comparisons, labeled our right triangle that we put on our paper. Now, before we get ready to plug into Pythagorean Theorem, we need to make sure we've written that down. Our a squared plus b squared equals c squared. And we have to be sure we correctly identify the hypotenuse as c. So we said that the hypotenuse was 2x plus 10. So I've got to be sure that goes in place of c when I plug into this. The 2 legs, it won't matter whether the shorter leg is A or the shorter leg is B. I just choose one of them to be A and one of them to be B. So I'm going to put in the shorter leg and square it, plus the longer leg, 2x minus 10, square that, and set it equal to the hypotenuse, which is 2x plus 10, and square that. So we have drawn our diagram, labeled our sides, written down Pythagorean Theorem, And we have plugged in those values on our right triangle to Pythagorean theorem. Now, here's where you got to be very careful and make sure you don't have an algebraic mistake. If I have any sides that are binomials, two terms, such as 2x minus 10, 2x plus 10, I have to be careful that when they are squared, I use FOIL. I don't square the individual terms. I have to multiply the parentheses times itself, which means I'm going to be using FOIL. So let's see if we can do that correctly. I know x squared is just x squared. If I'm going to multiply 2x minus 10 times 2x minus 10, I can either use FOIL, or if you're a little more visual, you can draw yourself a box and you can put each term of your binomial above each row and then again beside each column. And then this just organizes FOIL for you. You would put your answer when you multiply a row times a column in the box where they intersect. So for example, 2x times 2x is 4x squared. And 2x times negative 10 is a negative 20x. A negative 10 times 2x is another negative 20x. And negative 10 times negative 10 is a positive 100. If I have like terms, and this was written in descending order, which it is, then these like terms should show up on the diagonal. And I have circled a negative 20x and a negative 20x. Those are my like terms, and I'll add those together. So 2x minus 10, when I square it, gives me 4x squared, minus the 20x plus another minus 20x is a minus 40x. And the negative 10 times the negative 10 was plus 100. Now I need to expand the right side. And fortunately, because of the numbers that are involved, the only thing that's going to change from what I already have written is those minus 10s turn into plus 10s, which means that these negatives are now going to be positives inside my box. And that gives me 4x squared plus 40x plus 100. So I've now completed expanding these out. It's time to combine like terms. So what I see is I have x squared plus 4x squared on the left. That turns into 5x squared minus 40x plus 100 equals 4x squared plus 40x plus 100 on the right. And when I get my x squareds together, minus 4x squared from both sides, it's going to cancel on the right, and I'll have 1x squared on the left, which is a good thing because I do want to be able to combine those on the same side, since I still have an x squared term that tells me this answer is quadratic, and I will probably get two possible solutions for x when I finish solving this. And since it's quadratic, I'm going to move everything to the left. And when I do that, that means I need to subtract 40x. And by the way, it's not that you always have to move it to the left. I'm moving it to the left because I want to have my x squared term be positive. So I always start by moving the smaller of the x squareds to the other side so that I can end up keeping a positive value in front of my x squared. Well, a negative 40x plus another negative 40x is a minus 80x. But look at this. My 100s are going to cancel on both sides. And I'm left with x squared minus 80x equals 0. Now, that factors, and that's my easiest way to solve it. I could use quadratic formula, but why would I want to? I notice I have a common factor of x in both terms. So I'm going to factor out an x, and that will leave x minus 80 in parentheses, and that's going to give me two possible solutions. either x equals 0 or x minus 80 equals 0, which means x could equal 80. Now, at this point, I need to go back and see if both of these values would make sense in terms of the problem that we were given. Would it be a viable solution? And think about it, we were looking for, x stood for the shorter side. So would it make any sense for this side length to have a value of 0? Absolutely not. If that was a side length of 0, I wouldn't have a right triangle. So that tells me 0 can't be a solution, and therefore 80 would be the logical solution. So here's what we'll do. We will identify, because remember it said don't forget to answer the question that was in the problem. So we've got to find all three sides. And we need to pay attention to units as well. And this was in meters. So the short side is 80 meters. The longer side, or the longer leg, is 2 times 80 minus 10. And 2 times 80 is 160. 160 minus 10 is 150 meters. And our hypotenuse would be 2 times 80 plus 10. So that's going to be 170 meters. So you want to be sure that you have answered the question that you were asked, and you give all of the solutions that are required. Okay, we have one more example we're going to look at. So let me come up to height of a projected object. Projectile motion questions are very common in algebra, and we're going to see this example, or examples like this one, come up frequently. So this involves some kind of projectile, maybe a rocket, being launched upward from the ground with an initial velocity of 73.5 meters per second. We're going to ignore air resistance. That would be a force that would work on the object. So we're going to say, neglecting air resistance, the height of the object in meters above the ground, t seconds after projection, is given by this equation right here. And I have no idea why they decided they would use S to represent height, but they did. And so the height is equal to a negative 4.9 t squared plus 73.5 t. Now, do you recognize it's quadratic? I hope so, because there's a t squared in it. So that's how I know it's quadratic. And if we review a few things we should know about quadratic equations, why is there a negative in front of the t squared? Well, think about what you should know about parabolas. If it's a positive value in front of the t squared, your parabola would open up. But if it's a negative value, that parabola opens down. And if I'm shooting something up in the air, then what's going to pull it back to the ground? Gravity. That's why it's got to be a negative, because it's going to have to be a parabola that opens down. Also, for those of you who maybe have had physics, we know that gravity is a constant force here on the earth. And so if, depending on the unit we're working with, since this is in meters per second, that negative 4.9 is actually the force of gravity. So you're going to find any problem that involves shooting something into the air that's going to come back to the ground, if the units are meters and seconds, then that is always going to have a negative 4.9. If you're talking about feet per second, it's going to be a negative 16. So that's kind of nice to know why that negative 4.9 is there. It's not random. There is a specific reason for it. Also, did you notice the 73.5 in a different place in your problem? Absolutely. It was back up here with initial velocity. So the coefficient in front of your term that has just t is telling you what the initial velocity was. And you may notice there is not a constant added at the end. Actually, there is, although we don't see it. You could have written plus 0. Now, guess what that represents? Your starting height above the ground. Since this started from the ground, that's why there's no constant there. If it had started off the top of a building that's 100 feet tall, then we would have seen a plus 100 at the end. So that's just kind of helpful to understand how these quadratic equations are written, that they're not random. Those numbers have a specific meaning based on where you see them in the problem. So we're going to answer the question, after how many seconds will the projectile be 100 meters above the ground? Now, this did not give us any kind of a diagram. Since I do know that it is going to be an upside down parabola, I can draw one. You may find that helpful, and then again, you may not think you need it. But we do need to identify what it is we're trying to find. So if I look in this question, is it asking me to find a time, or is it asking me to find a height? Because remember, those are what the two variables represent. T represents time, S represents height. And the question says, after how many seconds will the projectile be 100 meters above the ground? Here's my question. So I am looking for time in seconds. And that means they must have given me the other value. We were given the height, which was the letter S for this problem. So we're going to plug in 100 for S and rewrite this equation. So here's what we know. We're going to put 100 equals negative 4.9 t squared plus 73.5 t. Now we want to set the equation equal to 0 and solve. Basically, we're back with what we were doing in the previous section. The hard part on this is just recognizing what is my equation asking me to find, and then how do I plug in order to find it. So to set it equal to 0, I'm going to subtract 100 from each side, and I get negative 4.9 t squared plus 73.5 t, and then I have minus 100 because I'm actually subtracting 100 from each side. Now, at this point, I've got some options. I can either choose to factor. I can see if the square root property is an option, or I can use the quadratic equation formula. Now, in general, if you see decimals like we have here, you're probably not going to want to factor. There are a few special cases where you might notice, I think this still is a good option for factoring because maybe I have a common factor I can pull out that gets rid of the decimals for me. But I don't think that's going to happen on this one. So I wouldn't recommend trying to factor. Also, keep in mind, if I'm looking for a specific time, time can be in fractions of a second. So it doesn't have to give me a whole number answer. It isn't a candidate for the square root property because look at your middle term. That b value in your middle term is not 0. And you only use the square root property if the b value is 0. Therefore, we're going to use quadratic equation formulas. So we're going to have to identify the a, the b, and the c. So a is negative 4.9, b is 73.5, and c is negative 100. So are you ready? We're going to sing the song. Da-da-da-da, 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 da-da-da-da. Negative b plus or minus the square root of b squared minus 4ac over 2a. That's our quadratic equation formula. And now we'll plug in the values. So we're going to have a negative, I'm going to put a parentheses for b, plus or minus square root of parentheses for b squared minus 4ac all over 2a. And now I'm going to plug in those values. So I'll have 73.5. And I'll put in another 73.5 for that b. My a is a negative 4.9. And my c is negative 100. And again, a is negative 4.9. So what I need to do is go through and clean this up. Remember, we're going to clean up under the radical first. And so let me make just a little more space over here. Hopefully I can get it squeezed in. And that means we have a negative 73.5 plus or minus the square root of, if I clean up what's underneath the radical, I should get 3,442.25, and that's going to be divided by a negative 9.8. Now, what happens is I go to my calculator and I figure out the square root of 3,442.25 is not going to give me a whole number value, but I do get two possible values for x. I have to work it one time using negative 73.5 plus the square root of this, take that number and divide it by a negative 9.8, and I work it a second time where I do negative 73.5 minus the square root of this and divide that by a negative 9.8, and that gives me 1.5 seconds, rounded to the nearest tenth, and 13.5 seconds. Now, you may be wondering, how is it possible that I get two different answers? Well, think about this for a minute. If you looked at this from the perspective of a coordinate plane, let's say right there is 100 feet above the ground. Do you see that there are two different times when it's going to be exactly 100 meters above the ground? So that's why you end up with two possible solutions for x. Now, sometimes you may work it out and one of them's negative. Obviously, time can't be negative, so that one's not a viable answer. But this one gave us two possible times because it's going to hit 100 meters on the way up and it's going to hit 100 meters on the way down. Now, there is a second part to this question. So let's pull it up and look at it. And the question is, how long will it take for the projectile to return to the ground? Now, I don't see any numbers in this. I still have that same equation, s equals negative 4.9 t squared plus 73.5 t. But then I have to ask myself, what is the height when it returns to the ground? Well, clearly, the height's 0. So guess what we need to do? We'll plug in that value for s. So 0, when it's on the ground, it's 0 meters above the ground. So 0 equals negative 4.9 t squared plus 73.5 t. And now we can solve this by, again, either factoring or the quadratic equation formula. And although these decimals are here, I can factor out a t from both of these, or I can potentially see if 4.9 divides evenly into 73.5. But let's say I didn't notice that. So if I just factor out a t, then I would have negative 4.9 t plus 73.5. And if I set t equal to 0, and I set negative 4.9 t plus 73.5 equal to 0, I can add the 4.9 t to both sides. And when I divide both sides by 4.9, I end up with t equals 15 seconds. Now, there's two answers here. One is t equals 0, the other is t equals 15 seconds. Think about it in terms of the problem. It's on the ground at t equals 0 before it gets shot up into the air. The question says, how long will it take to return to the ground? That answer is going to be 15 seconds.